Alright, yeah, so good morning. How are you? Hope you are good. So I'm going to solve this. I will be solving these questions for you and I will be explaining in depth. Right? Alright, so the first one says a mirror of weight 75 Newton is hung by a cord from a hook on the wall. If the cord makes an angle of 30 degrees with the horizontal, then the tension in the cord is. So what you just have to do is, let's say we have this as our tension T and T and they say it makes an angle of 30 degrees to the horizontal, so meaning here is 30 degree, this place also is also 30 degree. So and the weight, the weight of a body must always act downward, so the weight of the mirror will be acting downward here, which is W equals 75. Are you following me? All right, sorry, 75 Newton, not degree. Alright, now this particular diagram, we call it a free body diagram, is going to be in a static equilibrium. So meaning that the upward forces will be equal to the downward forces. The upward forces will be equal to the downward forces. Now what you just have to look for is, you need to get T. You have to go and get your T. Now the upward forces here is, anytime you are dealing with upward forces, we make use of sign. Upward and downward forces, we make use of sign. If it is left and right, we make use of cos. Vertical component is always sine, horizontal component is always cos. Take note of that. So if I say up and down, that's sine. So meaning that I can say that my summation Fy, because I'm dealing with vertical component, is going to be T. Then don't forget you are picking sine. The angle between that T and the horizontal is what you are picking. That's 30 degree. Then plus we still have another T sine 30 degree. Then plus, I'm done with the one upward, then the downward part is W, so we can pick this as into brackets, but because it is downward, you have to take a negative, so that's minus W sine. The angle between this line and the horizontal is actually 90 degree. Have you seen that? It's actually 90 degree, so I'm picking 90 degree here. So I'm picking 90 degrees. So meaning my summation Fy now will be equals to T sine 30, right, plus another T sine 30, then minus W sine 90, right. So now at equilibrium, your summation Fy is equals to 0 when you are dealing with equilibrium. So meaning my T sine 30 plus T sine 30 minus W sine 90 is equals to 0. That's what that thing is trying to say. Is equals to 0. Alright, so from there, T sine 30 is 2 T sine 30, 2T. If you add them together, that's 2T sine 30 equals, then W sine 90 can go to the other side. That will now be positive W sine 90. So just try and do substitution. 2T into sine 30 is 1 over 2. That's a special angle, 0.5, 1 over 2. Because our W here is given to be 75 Newton from that question. Into sine 90 is 1. Our sine 90 here is 1. So what you just have to do here is 2 can cancel 2. Right? Then meaning T is equals to 75 Newton. Now if you look at the option, there is nothing like 75 Newton there. So what this question is actually asking is the summation. Right, so meaning is asking that what is T plus T. That's what the question is asking, meaning 75 Newton plus another 75 Newton, and the answer will be 150 Newton. So that's what the question is asking, and that's option D. Do you get that? Okay, so you can pause the video, take it backward in order to see what I'm talking about. So let me pick the next question. I'm trying to pick the questions from here. Copy the image. Alright, let me paste it. Alright, so please, I just want you to listen and listen good. Listen and listen good. Alright, it's loading. Let me allow it to load. Maybe that's network. I don't know why it's taking time like this. Okay, that's loaded. Alright, so this is another question. Now the first thing that you have to do anytime you are solving physics question, you need to know the topic that the question is being brought out from. you need to know the topic, you need to know the subtopic. Now this question is actually coming from equilibrium of forces as well, so but it's coming particularly from moment of force. It's coming particularly from moment of force, and moment of force is just the product of force and the perpendicular distance. Just take note of that, product of force and the perpendicular distance. And there are two basic things that you need to know about moment of force. Number one is that for any uniform beam or any uniform meter rule, the weight of the meter will always act at the midpoint, at the center. So if they give you uniform meter rule of 100 centimeter, the weight of that meter rule itself will act at 50 centimeter. If it is 4 meter something that they give to you, the weight of the meter rule will be acting as 2 meter. Take note of that. All right, but here they say they did not even bother to tell us the weight of the meter rule here, so we don't really need to put that into consideration. Do you get it? So you don't need to put that into consideration. So let me just redraw the diagram. They've actually drawn the diagram for us, so let me just try and redraw it and do something. So here is 200 gram and here is 500 gram, right? So they say from here to here to the fulcrum, this is what we call fulcrum or support, is 20 centimeter, and from here to here is also 20 centimeter. Follow me. Now from here to here is given as x. So now the question says we should look for x. That's what the question wants us to look for, that we should find x. Now according to principle of moment, we have what we call principle of moment, and the statement is that the sum of clockwise moments must be equal to the sum of anti-clockwise moments. When I say anti-clockwise moments, you are moving in opposite direction, in the direction of the clock. If you look at your clock very well, you will see that your clock always moves like this, right? So this is the clockwise, but we are going like this. This is anti-clockwise, this is clockwise, this is anti-clockwise. That's number one. Or you say the algebraic sum of the moments is equal to 0. You can also say that the algebraic sum of all the forces is equal to 0. It's still under it. So you have to take a reference point. So me taking my reference point now, I will use this fulcrum as the reference point. So I will say taking moment. I'm going to say taking moment about the fulcrum. So I want to take moment about the fulcrum, meaning that whatsoever thing I want to bring must be coming towards the fulcrum. So I will bring this one like this, coming towards the fulcrum. I'll bring this one like this, coming towards the fulcrum. I'll bring this one like this, coming towards the fulcrum. Now the first one that I brought here is actually in clockwise direction, but these two are in anti-clockwise direction. I believe you are following me. Both of them are in anti-clockwise direction. So from here now, I already told you what to use. You are using clockwise moments is equals to anti-clockwise moments. Normally the basic formula should be force times distance, but instead of using this Jamb, this is not WAEC. So instead of using force times distance, you can just use your mass times perpendicular distance straight away. Mass times perpendicular distance. So meaning I can say 1000 times, what's the distance between here and here? Between 1000 gram mass and this, if you look at it, the distance is 20 centimeters. So that's times 20 equals, we are done with the first one. Now anti-clockwise moment, I want to pick the first one, 200 gram. So I'm picking 200 gram, then times, what's the distance between 200 gram and the reference point, which is the fulcrum? The distance is x, plus we still have another anti-clockwise, which is 500 grams. So that's between 500 gram and this is actually 20 centimeter. If you look at it, it's also 20 centimeter. From here to here is 20 centimeter. So I will pick 500 times 20. So just do your normal math. This should be 20,000 equals, this should be 200x, and this should be 10000. That's 10,000, right? So collect the like times. I can say 200x equals 2000 minus 10,000. 2000 minus 10,000. So that's 200x equals 2000 minus 10,000 will also give you 10,000. So how do we get x? From here, if you want to get your x, you divide both sides by 200, right? So divide this by 200 as well. Cut. So our x now is 100 over 2, which is actually 50 centimeter. Are you following me now? So that's how to go about that. The answer is 50 centimeter. Okay. All All right, so it seems we are done with that. So it's 50 centimeter, then meaning from here to here will be, from here to here is 20, then from here to here is 30. Okay, so that's how to go, about that. That's how to go about that. So you can try and look at it over and over again. You can try and look at it over and over again. All right, so now moving on to the next question. Let me see the next question here. Okay, copy image, then paste. Copy image, then paste. I've copied the image and okay, I've pasted it. I've copied the image and I've pasted it. So we'll be solving this one now. Alright, so that's what I'm doing currently. You can see. So I'm trying to record this thing for her and send to her. You can see. Alright, so now a mirror of weight 75 Newton. Okay, it seems we've done this. So don't let me do it again. I've done that. So let me pick the next one. I've done that. So let me pick the next one. Okay, it's loading as well. So let's wait for it to load. Let's wait for it to load. Okay, has it loaded? Okay, it has loaded. Let me cancel this one. Okay, no. All right, so let's look at this now. It's still actually, this question is actually coming from that same moment of force. They say a seesaw pivoted at the middle is kept in balance by weight of Richard, John, Philip, such that only Richard, whose mass is 60 kilograms, sit on one side. If they sit at distance 2 meter, 3 meter, 4 meter respectively from the pivot, Philip is 15 kilogram. Then I say find the mass of John. So this is what we are doing now. This is the meter rule or the seesaw. Now the seesaw is pivoted at the midpoint. Let's say this is the midpoint. All right, please follow me. Now by weight of Richard, okay, we have Richard, John, and Philip, such that only Richard sit on one side, right? Richard sit on one side, and Richard is sitting on 2 meter distance. So this is 2 meter, and this is where Richard is sitting. And Richard has a mass of, let me call it MR. Richard, mass for Richard, 60 kilogram, and he's the only one sitting on one side, right? On one side. Now, why the other person is sitting 3 meter? Let's say we are moving from 0 meter. From this end is 0 meter. So the other one is sitting on 4 meter, 3 meter, and 4 meter. So meaning that John is sitting on 3 meter, right? John is sitting on 3 meter. So let's say we have the 3 meter here. John is sitting here. So let me call this one mass of John. So I don't know, did they give us? No, they did not give us. That's what we are looking for. And we also have another person, Philip, which is 4 meter. So let's say 4 meter is here, and that Philip has a mass of MP. It has a mass of 15 kilogram, right? So we are looking for MJ. So what you just have to do is you take moment about a particular point. We take moment about a particular point, though we don't really know the same midpoint, but we don't know the midpoint of this thing. We don't actually know. Assuming they give us the total length now, it would have been easy for us to get the midpoint, but they did not give us the total length. Are you seeing that now? All right, so but let me just pick this. Let me just pick this as S. Let me just say this is X. Let's just agree that it's S. So I want to take my moment. I want to take my moment about taking moment about the pivot. So meaning I'm going like this. Let me change my link. I'm going this way. I'm going this way. We don't know it, so let me just agree that it is X. All right, so now don't forget how we used to pick it. This one is clockwise, this one also is clockwise, this is anti-clockwise, and I told you that your clockwise moment must be equals to anti-clockwise moment. So the clockwise moment that we have here is MP. That's our clockwise moment. The clockwise moment that we have here is MP. the clockwise moment that we have is MP. So sorry for that. No problem. Sorry, hold on for me, please. I need to. Okay, so now AC CW is okay, MP. So I'm using mass of Philip first. That's 15 into bracket. The distance between them. Actually, the reason why I say this question is incomplete is because they did not really give us the distance that we need here. They did not really give us. We need to know what is here. If we should know what is here, it will be easy for us to solve. We need to know. But let me just agree that 2. Let me just take 2 straight away. Let me just take the 2 straight away. So let me check with that first. So this one is 4, 15, then plus the mass of John we don't know, and this one is 3 equals the anti-clockwise is 60 into, let me take this as 2. So this is 60 plus 3 mg mass of John equals 120. So from here we can say 3 mg equals 120 minus 60, and 120 minus 60 gives 60 as well, right? It gives 60 as well. So meaning 3 mg will be equals to 120 minus 60 is 60. So your mg, the mass of John now, will be 60 over 3, and that will be 20. So I'm picking this. I don't know how accurate that will be, because normally they're supposed to give us the midpoint. We need what is here, but let me just agree that that is what we have, like taking the midpoints be equal for all of them, and picking the midpoints being equal for all of them. All right, so we are going for that. Let me move on. Let me pick another one for you now. All right, so I'm done with this. Okay, all right, so picking the next one, copy image, and let me paste. Copy image, then paste. All right, it's still loading. Okay, so this is what we have. They say 2 force of 10 Newton act on a body, one towards the north and the other towards the east. The magnitude and the direction of the resultant force. So this one is talking about resultant force, right? So we have a particular body here, and there are 2 equal forces of 10 Newton acting on the body. One is acting this way, 10 Newton due north. Another one is acting this way, 10 Newton due east, right? You know, this is your north and this is your east. So they say, what is the resultant? What you just have to do is you pick a diagonal from here like this, and this will be your resultant, right? So this is all actually under Pythagoras theorem. That's what you will use to just solve this one. So to do this, you just use your r squared equals 10 squared plus another 10 squared. So your r squared here will be 100 plus 100. So our r squared here will be 100 plus 100 will give you 200, right? That's 200. So how do we get r? We get r by looking for the square root. So square root of 200 gives, that's square root of 2 times 10. I'm using sword. Sorry, 2 times 100. I'm using sword now. So square root of 10 is 10. Then root 2. Don't forget this in sword. So we have 10 root 2. Now the next thing that you need to look for is the direction. Now if you want to pick the direction, it must always be the angle between the resultant line and the horizontal. So meaning I'm talking about this angle. Let me call it alpha. This is the resultant and this is the horizontal line. So you are looking for alpha. But if you look at it, if you have 10 Newton here, it actually means that 10 Newton also will be here, and this place also is 10 Newton, right? And this is right angle. So this is what we call a right angle isosceles triangle. Right angled isosceles triangle. Meaning if this side and this side are the same, then they must also have the same angle. Meaning if this place is alpha, this place also must be alpha. You can go and read more on right angle isosceles triangle. This is what I'm saying. If you have something like this, this is what we have. we have this and this being equal. It means the base angle also must be the same, and we already pick this one as angle 90. So automatically you should know that alpha plus alpha, which is 2 alpha, plus right angle 90 will give us 180, right? And that will be 2 alpha equals 180 minus 90, right? So 2 alpha now will be 90. To get alpha, you divide both sides by 2, right? So alpha is 45 degree. You've gotten your alpha to be 45 degree. Now this is 45 degree, alpha is 45 degree, meaning that the remaining side here also must be 45 degree. Don't forget north and east. But what they want you to use here is a compass bearing. You know, we have two forms of bearing. We have the surveyor's bearing and the compass bearing. So if I want to pick the compass bearing now, it's going to be north. You pick north. North must always be your reference point. So north 45 degree east. I'm talking about this 45. I'm talking about this 45. This one here, not this one. So assuming this place is 30, you know it will be 60 here. So you will say north 60 degree east. Do you get it now? So this is north, but for this one it is north 45 degree east. So that should be the last option, option D. That's the last option, option D. So that's how to just calm down and look at it and check the right thing to do. It's very easy. It's very easy. Very easy. The direction that I want to pick must be the angle between the horizontal and the resultant line. Please take note of that. So at the end of the day, if you now want to use compass bearing, you now try to look for a way of resolving it, but it must always be the angle between your resultant and your horizontal. That's the first angle that you need to go and look for, which is my alpha here. So after doing that, you can now make use of maybe surveyor's bearing or compass bearing. Do you get it? What I'm trying to say is that assuming when you do it, you get something like, let's say you get 135 now. You know 135 normally will come from here to this place, right? This is 135 degree. Surveyor's bearing will tell us that this is 135 degree. But in compass bearing, if this place is 135, then the remaining angle here is 45, right? So in surveyor's bearing, I will say this is south 45 degree. In compass bearing rather, south 45 degree east, or 135 degree. So you can try and look at more of that. So it's very easy. Just calm yourself down and look at it. Okay, copy image. Let me paste another one. Don't forget the logic. Anytime you see a question, you have to ask yourself this question: which topic is it coming from, and which formula am I to use? Which topic is this question coming from, and which formula am I to use? So that's the first thing. Okay. All right, light of waves. So we have this light of wavelength. So you should know that this is actually coming from wave, right? And it is coming from refraction of light, specifically refraction of light waves. Another refraction of light waves, we have what we call refractive index. There are different formulas for refractive index. We have sine I over sine R. This is one. This is what we call Snell's law, right? We also have n is equals to wavelength in air, or wavelength of light in air. We can use that word, over wavelength in medium, wavelength of light in medium. That's formula for refractive index. Or you say velocity of, or the speed of light in air, speed of light or velocity of light in air, then over velocity of light in medium. Your medium can either be a glass or water, because that's we just have three media. It's either they use air, glass, water. But for this one, it is let me see, they are talking about glass here, so that will be over glass. The medium is glass, right? All right, but the question says we should calculate the what? The question says calculate the what is the wavelength in glass of the refractive index. So meaning what you just have to use is, the formula to be used here is n is equals to wavelength of light in air, wavelength of light in air. When I say air, I'm trying to say the free space. In free space, let me just write what is here. Then over the wavelength over the wavelength of light in glass. So we are given refractive index. The refractive index is 1.5, right? Equals to wavelength of light in free space is given to be 5,000 times 10 raised to power minus 5, right? Okay, so over, let me zoom in so that I can see very well. Okay, minus 5 centimeter over, then for the wavelength in glass we don't know it, so let's call it lambda g. So lambda g now, if we cross multiply, it means 1.5 lambda g if we cross multiply equals 5,000 times 10 raised to power minus 5 equals 5,000 times 10 raised to power minus 5. So meaning my lambda g now will be 5,000 times 10 raised to power minus 5 over 1.5 So what you need to do is just do your, you can even write this in terms of indices, but because if I want to write in terms of indices so that it will be easy, you can say 5,000, because there is no calculator, right? So you can write it as 5 times 10 raised to power 3 then times 10 raised to power minus 5. I'm trying to use law of indices for you. Then over this 1.5 actually means 3 over 2, so that it will be clear. So these two can come up, so meaning I can write it as 2 times 5 then times law of indices 10 raised to power 3 minus 5, law of indices, then over 3. So this will be 10 times 10 raised to power minus 2 over 3, right? And what's 10 over 3? 10 over 3 should be 3.33 something, right? It should be 3.33 something. So we can write this as, that's 3.33 times 10 raised to power minus 2. That's what I should have, times 10 raised to power minus 2. So but here they are writing times 10 raised to power minus 8. I don't know why they are writing that. Maybe what they wanted to write here is 5 times 10 raised to power minus 8. Probably. But that's how to go about that. In case you see questions like that, that's how to go about it. Okay. Alright, so let me pick another one for you. Okay, copy image, then paste. Alright, so let's look at this question. An electric heater is used to melt a block of ice of mass 1.5 kilogram. If the heater is powered by 12-volt battery and a current of 10 amperes flows through the coil, calculate the time taken to melt the block of ice at 0 degrees C. So you just want to melt this one. This with latent heat, right? It's actually coming from heat and temperature. We have what we call latent heat of fusion and latent heat of evaporation. Latent heat of fusion is telling you that it is coming from solid to liquid, right? Or you see, it's actually defined as the amount of heat required to change the state of a body from a solid state to a liquid state without change in temperature, right? Without changing. That latent heat is also known as invisible heat or hidden heat. Okay, so now looking at this particular question here. Alright, so you need two things. Number one, you need to know the formula, and you need to know how to make use of conservation of energy, right? So the first thing is, if I want to go and look for the Q under latent heat, we write it as MLF. Now if you want to look at electrical energy, this one is heat energy, this one is heat energy or thermal energy. If you want to go and look at electrical energy, we are using Q equals we can use IVT. Let me see, we have current, voltage and time. Is the time that they say we should look for, so we can use IVT. So if we relate the two of them together, this is electrical energy. Please don't forget, this is electrical energy. This is for electrical energy. So if we relate the two, Q can be equals to Q, meaning MLF will be equals to IVT. And you are looking for T. If you divide both sides by IV, you have MLF over IV. What does M stands for? Your M stands for mass. Your LF stands for latent heat of fusion, specific latent heat of fusion of ice. your I stands for your current, and your V stands for your voltage or potential difference. All right, so for this question now, the mass given to us is 1.5, and the latent heat of fusion is 336 times 10 raised to power 3, then over your IV. We are giving IV to be, I is the current, and that's 20, and we are giving our voltage to be 12, right? So meaning our T now will be equals to, so in order for this to just make use of, you can use your head, but I guess they do provide one small calculator on the system, so you can just use that to do it and get your answer and move. Over 20 times 12, so I got 210. I got 210. Now this one is 210 seconds, right? It's in seconds, but if you look at the options are in minutes. So how do we take seconds to minutes? Seconds to minutes is we divide it by 60, right? We want to take seconds to minutes, we divide it by 60. So I will try and divide this one by 60 now. So divide by 60, that will take it to seconds, to minutes rather. Divide by 60 to minutes, and that will be 35.0 minutes, which is this. I'm using black, which is this, right? So that's how to do that. There are many, actually. We also have the one for specific capacity. Q is equals to MC change the theta. We have this one too. We also have Q is equals to MLV. This one is specific latent heat of vaporization, meaning you are changing from liquid to gas. Like fusion, now fusion is from solid to liquid. Vaporization is from liquid to gas. I believe we are taking note of the difference between them. Now this one is specific heat capacity. This one is just when you are dealing with change in temperature. M is mass. The C that you have here is specific heat capacity. The change in temperature is the final temperature minus the initial temperature. You can also have this one as well, CP, change in theta. There is also another one like this. This one is talking about heat energy. CP means heat capacity. While change in temperature is the final temperature minus initial temperature. This and this can work together depending on their specification. Alright, so that's how to do that. Okay, so let me see which other one do we have. I've solved this, and let me go down a bit. Wow. Okay, so let me see the next question here. Copy the image, then paste. Let me paste it. Alright, so they say the function of a 5 ampere fuse included in a circuit supplying a household refrigerator with the power is 2. The answer is to keep the current supplied to the refrigerator below 5. That's the answer, below 5 newton. What fuse actually? The function of fuse is to keep the current supplied to the refrigerator below 5. To protect, it can be used to protect the motor and to protect fire hazard too. It is used to protect fire hazard and to keep the current within a safe limit. For instance, the safe limit here is 5 amperes, right? So what the fuse is trying to do is it will keep current supply to something below 5 ampere. Are you getting it now? So it's just a theoretical question. All right, so let me see. Okay, other one that we have here. Copy the image and paste. Okay, I'm waiting for it to load. Okay, it seems it has loaded. All right, so they say a handbag containing some load weighs 162 newton. You should know that the load will have a weight, and that weight will be acting downward, right? It's carried by 2 students, each holding the handle of the bag, right, that is next to him. If each handle is put 60 degrees to the vertical, they say find the, now we have to be very careful. This one is talking about vertical, not horizontal. Find the force on each student arm. So it's still under static equilibrium. So we have a bag. This is how this one will go. So the weight of the bag will actually be acting downward. Don't mind don't mind my line, no? So it will be acting downward. So this is the weight of the bag, and we can just produce a line here. We can actually produce a line here. Okay, all right. So now they said to the vertical, not to the horizontal. Don't forget, to the vertical. So meaning the angle to the vertical here is 60 degree. One arm 60 degree, another arm 60 degree. Now the remaining angle here should be 30 degree. Don't forget, this is a right angle. If you look at it very well, this is a right angle, right? So meaning the one here also should be 30 degree. Both of them are applying the same they are applying the same force, right? Applying the same force. So the force, so that it will be balanced, for it to be in equilibrium, they should be applying the same force. So let's say this one is applying force F1, and this one is applying force F2, F1 and F2, F1 and F2. Just follow the other one that I did for you. It's still the same thing. So what you just have to do here is you can make use of vertical component as well. So don't forget, I used to say summation Fy will be equals to upward forces, right? Summation of all the upward forces and downward forces. Okay, so the upward forces here are F1 and F2. The downward force is just W, which is 162 Newton. So don't forget, we are dealing with vertical components. So that will be F2 then sine 30. The angle that I want to pick must be between the line of action of the force and the horizontal line. So meaning between this and this is the angle that you need to take, 30. Then plus, we still have another one there, F1 too is there. So F1 sine 30 as well. Then plus into minus, this one will be minus W sine. Now you should know the reason I'm picking minus, because it's a downward force. That's negative, right? Negative y-axis. And the angle between the line of action and the horizontal here is 90 degree. You can see perpendicular. So sine 90 degree. And I told you that at static equilibrium that your summation Fy will be equals to 0. Don't forget that. So meaning I can say F2 sine 30 then plus F1 sine 30 minus W sine 90 will be equals to 0. So don't forget, your F2 and your F1 is the same. So let's just say that they are the same thing as F. So I'm picking all of them to be F. Right? So meaning I can say, now this returns to F sine 30 plus F sine another 30, then minus our W here is 162. So 162 into sine 90 is 1, which is equals to 0. F sine 30 we give 2 F sine 30. Now equals to, let this 162 go to the other side. That's equals to 162. I believe you are following me. Alright, so from here now we can have 2F into sine 30 is 1 over 2, a special angle, equals 162. 2 will cancel 2. So our F here is actually 162. So each of them, the force on each student arm is 162, which is the last option there. Option D. Okay. But if they say what is the total force, that will be 162 plus 162. That will be 162 plus 162. Okay, so let me pick the next question. Copy, then paste. Copy, then paste. Let me paste it. Alright, it's loading. Let me wait for it to load. It's loading. Alright, so this is a particular question. You should know where this question is coming from. This question is coming from extension, elasticity. It's coming from elasticity. They say calculate the tension, the extension of the spring per unit load. So what we are looking for is extension over load. And extension over load actually means extension over force. That's E over F, and E over F actually means 1 over K according to Hooke's law. So your extension over load according to that question actually means your change in extension over your change in force, right? Or your phase. Alright, so Now they gave us W1 here. Our W1 is they gave us W1 to be 200 gram and W2 to be 450 gram. So I don't know what they are trying to say. Maybe they've measured the weight, right? But let me just agree that they've not measured the weight. Like, they did not measure the weight. The only thing that they are talking about is the mass. You know, you cut it off, I can't really see everything. So let's just agree that they actually cut the mass, or they've even done the conversion, So meaning that my change in force will be, that should be W2 minus W1, and that will be 200G. This 200G, I don't know what it stands for. Maybe they are trying to say that is the well, let me just say it is mass. Let me say it is 200 gram. You get 200 grams. So let me just say it is 200 gram. So meaning the mass for the first one is 200 gram. Please follow me and look at what I want to do. 200 gram. Change it to kilogram. That's divided by 1000 for the first one, rather for M1. So change it. That's 200 gram divided by 1000. That will take it to kilogram. So M1 here is 0.2. That's 0.2 kilogram. Now to weight. So to weight, just times it with 10. That would be 2 Newton. To weight times it with 10. That's 2 Newton. Alright, so if you do the same thing for W2, it's still the same thing. For W2, you know it's 450. So for W2, it will be, okay, maybe I should do that for you as well. Let's do for W2 too. M2 is 450 gram. I'm just agreeing it is gram. So M2 now will be 450 gram divided by 1000. We are changing it to kilogram. So our M2 here will be 1, 2, 3. That's 0.45. 0.45 kilogram. Now change it to Newton. So W2 will be, just times it with 10. You know W is equals to mg. Acceleration due to gravity is your g. So just times it with 10. That's 4.5 Newton. Okay. So now come back to the question. W2 here is 4.5 Newton. W1 is 2 Newton. So meaning we are going to have 2.5 Newton here. So we've gotten the change in force. So let's try and look for change in extension. Change in extension is here. Now this thing is actually measured in centimeter. Maybe from 1 to 10 centimeter, I don't know. But let me just agree that it is measured in centimeter. Alright, so in centimeter, if you look at the first one, what I'm doing is extension 2 minus extension 1. Extension 2 is where is it now? The longer one is extension 2, and that's on 5. You can see this is on 5. So that's on 5 centimeter, minus extension 1 is on 4 point. I'm coming. Okay, sorry, this should be on 6.5. This is 6.5, not 5. This should be 6.5. Yes, this is 6.5. So here is 6.5 minus E1. This is it, the first one here. That's 5. So if we try to subtract, that's 1.5 centimeter. So to meter, you divide by 100, and that will be 0.015. 0.015. Right? No, that should be 0.0015. 0.0015. Because normally this is 1.5. Then I want to do times 10 raised by minus 2 to meter. I'm trying to change it to meter. So it actually means 1.5 divided by 100. And that should be 0.0015. 0.015. That's 10 raised by 3. What am I? You are counting. What you want to do here is you are trying to count 2 times. You are counting 2 times. 1.5. So 1, 2, then 0.0. So that should be 0.015. Right? 0.015. So it's 0.015 meter. That's what we have. That's the change in extension. So you go back to the original question. That's your change in extension. To the original question now, change in E over change in F will now be the extension is 0.015 meter, and this one is 2.5 n. So 0.015 divides 2.5. So this is 0.06006 Newton meter per Newton. or you say 6 times 10 raised to the power minus 3, or you say 6 times. So please, you need to be very, very, very careful with conversion and the way you are using your indices. You know, this one almost got me confused, but I just need to do some things. So this is it here. Please take note of that. So that's how to solve that one. That one also is cleared. That one also is cleared. So let me pick the next one. This particular one, copy. This particular one, copy. Alright, so let me paste it. It's still loading. Okay. Alright, so the question is here already. They say in the calibration of an ammeter using, this one is under current electricity. Okay, sorry, this one is under electrolysis. It's under electrolysis. They say in the calibration of an ammeter using Faraday's law of electrolysis, the ammeter reading is kept constant as 1.2 ampere. Right? So if 0.990 gram of copper is deposited in 40 minutes, the correction to be applied to the ammeter is, so meaning you just have to go and look for a current first, right? And according to electrolysis, M is equals to ZIT. That's all we have. But we don't have the Z is electrochemical equivalent, ECE, right? Or you call it a constant. It's actually a constant. The I is current, T is time, M is mass. Now, but since they did not give us Z, there is something you can do. There are some manipulation that you can use. The element they are talking about is copper, and copper is a what? A divalent metal, Cu2+. The molar mass of copper is I don't know, 64 or 63.5, but let me use 64. So the logic that you will do is this. Please, I want you to listen. You pick the mass 0.990 gram equals, you now relate with it your IT. We don't know the I, but we know the T to be 40 minutes. Don't forget, you need to change this minutes to seconds, right? So that's times 60. You need to change minutes to seconds. It will take it to seconds like that. That's the first thing. Now the second thing that you will need to do is you now pick the molar mass of copper, 64 gram, equals how many Faraday is going to be there? That's 2 Faraday, because you have 2 plus, so that's 2F. That's 2F. So from here you cross multiply, this one comes here, this one comes here. That's the idea. You can see the idea that I'm using. I related mass equals IT, and I related the relative atomic mass equals 2 Farad, the number of charge. Then you cross multiply the two equations. So from here, if you cross multiply, it means I times 40 times 60, then times 64 will be equals to 0.990 times 2F. You know what your F stands for? That's 1 Faraday, and 1 Faraday is 96500, right? So this is I times 40 times 60 times 64 equals 0.990 times 2 times 96500, 1 Faraday. Okay, so what you just need to do here is you just use your normal use your calculator to calculate this. So it is 96500 coulomb, right? 96500. Alright, so let me use calculator to times this. 40 times 60, that's 2400, then 2400 times 64. That's what you want to do. So meaning this will be I times 153600 equals, then the other side, the left hand side, 0.990 times 2 times 96500. That's 191070. So our I now will be equals to 191070 over 153600, right? So divided by 153600. So I got 1.2 something. I equals 1.244. Let me pick that. 1.244. Now if you look at the question, they gave us 1.2. So meaning we are doing the correction now will be the answer that you get as your current 1.244, then minus the main current that they give 1.2, right? So 1.244 minus 1.2 will give you 0.44. I'll be 0.044. Approximately it will be 0.04. This is it. But most times they used to tell us what the relative atomic, because some of them used to use 63 points. We have people, some used to use 63.5. You get. So maybe when you are less busy, that place that I put 64, put 63. Okay, maybe I should just do it. This place where we have 64 grams, let's check if it is 63.5. Let me see what will be there. If it is 63.5, let me see what will be there. 63.5. Now for this one, if I use 63.5, I will have 1.25. So you need to be very, very careful. I will have 1.253. So approximately the correction here will also be 0.05. So it depends on what they are using. If it is 64, good. If it is 63.5, good. But maybe I will have to confirm for you to know what they are using, because we need to round it up. Let me check. Relative atomic mass of copper. Let's see if they are using 63 points. Okay, now this one they are using 63.55, and that's 63.6. Some is using 63, so it's just better to just use 64. Do you get? So that's that. But most times they used to mention that, okay, oh yeah, you have to use 64 points, 64 grams. Yeah, you have to use 63.5. all right. Okay, so the next question is loading. It has loaded. All right, they say all the three forces must be coherent. So this one is talking about coplanar forces in equilibrium. The three conditions are very, very right. Sorry, I picked the wrong one. Hey Jesus, Ctrl Z. Okay, this is actually wrong. It should be I and I. It should be this. The three of them is right. All the three forces must be concurrent. The upward force, I already made mention of something like this. Upward force must be equal to downward force. In another way, they can say the algebraic sum of the forces must be 0. It's still the same thing. Number 3, the algebraic sum of the moment about any point of 0 is actually correct. Or they say the sum of the clockwise moment must be equal to sum of the clockwise moment. So take note of that. The three conditions are very, very correct. Alright, so that's that. So let's check another one. Okay, it's loading. Alright, okay, so it has loaded. Let me bring it here. Alright, so now don't forget I used to tell you that the first thing that you need to know is this question is actually coming from where. So this particular one is coming from machine, right? It's coming from machine. Alright, so but this is a block and tackle system. They say if the efficiency, okay, so they are dealing with efficiency. The formula for efficiency normally is work output over work input. Work output over work input. Work output over work input times what? 100%, right? So in another way, you can see them saying MA, mechanical advantage over velocity ratio, VR, times 100%. It's still the same thing. And you can also see them saying efficiency is actually load times distance moved by load. Load times distance moved by load. Distance moved by load. You can also see them writing like this: over effort times distance moved by effort. Effort times distance moved by effort. Effort times distance moved by effort, then times 100%, then times 100%. So that's it. Alright, so but for this particular one, let's see what is there. They say we should find how much work is done against friction. That's what they want us to look for. Work done against friction. So what you need to do is you go and look for the input work. right? You need to go and get the input work first. So, but then we can say efficiency is actually, for the work output, I can say load times distance moved by load. Load times distance moved by load. Load times distance moved by load over. Now, instead of saying effort times, you can just say over work input. Do you get over work input? Then don't forget, we always put times 100%. So that's what we'll be using. So for this question, the efficiency is given to be 40%. That's the efficiency, 40%. Now if you put ordinary 40 here on the right hand side, you put times 100. But if you put 40 over 100 on the right hand side, we won't put times 100 again. So now if I put 40 over 100 here, I'll just say my load. If you read the question, the load is 20 Newton. And the distance moved by the load here is 10 meters vertically. Then over the work input, let me just say input. We don't know the input. You can see that I did not put times 100 here again. Why? Because I already put over 100 here. But assuming it's ordinary 40, you have to put times 100. Do you get it now? Alright, so this will be 40 over 100 because this is 200 over the input. So you have to cross multiply, meaning your 40 input, 40 times the work input equals 200 times 100, that's 20,000, right? That's 20,000. To get input, your work input now will be 20,000 divided by 40, right? 0 comes 0. So so we have 500 joules. That's the work input. The work input is 500 joules. Now, but what the question is asking for is the work done against friction. So the work done against friction now will be work done against friction. Work done against friction will be work input minus work output. Work input minus work output. Your work input is the load, your work output is the load times distance moved by load. That's 20, which I wrote here. It's already here. That's 20 times this. That's your work output. But the work input, we've calculated it to be 500 joules. So it means 500 joules minus the work output. I already told you that work output is load times distance moved by load. That's 20 times 10. That's your work output. So don't forget joule is here too. So that's 500 joule minus 200 joule. And what you have here is 300 joule. So let's check. Is it? Yeah, it's there. Okay. That's option B. You can see that. So that's how to. You just have to calm down. You calm down, look at the question very well before you start doing anything. Okay, so that's how to go about that one. That's efficiency of the machine. Okay, copy image, then paste. Let me paste the next one. It's still loading. Alright, so for this one, this is a theoretical question. They say they say two insulated charge spheres of different sizes and carrying opposite charges. Opposite charges, one is carrying positive, another one is negative. Alright, are connected together by metallic conductor. Current will flow from one sphere to the other until both spheres are at same potential. That's the answer. You don't need to stress yourself. They are at the same potential. That's that for that. Okay, the last question, I guess. Okay, so maybe after this last question, I will also try and look for another free time of mine. So I will just give you another free 1 hour, then do video like this for you and send. So maybe from the other part that you sent to me, we do it that way from there. Okay, so let's look at this question. They say a body on the ground is acted upon by a force 10 Newton. You can see where that 10 Newton is. Then I say at a point P as shown in the figure above, what force is needed to stop the body from moving eastward? So what you just need is you need to go and calculate the force towards the other point. This one is 60 degrees, right? That's 60 degrees, and this is point P. This is another point, and This one is 10 degrees. So what you need is, you need to go and get this particular one here. You need to go and get this particular one, but you have to be very, very careful. If you look at this question very well, what they gave you here is actually your what they give you is actually your resultant. That's what they give you, and you can see where the body is, and you don't want the body to move towards east. You can actually make use of 10 cos. Do you get? You can just use 10 cos 60. You can use 10 cos 60 to get it, but I will advise we try and do it this way. Let's say they both have the same force, like they are of equal length, P and the other one here, right? They are of equal length. So we can say that I want you to follow me and get something. I already said what you can use straight away from it, that you can just say for that I will just use 10 cos 60, and cos 60 is 1/2, so that's times 1/2, 5 Newton straight away. But I'm trying to see if there is another way of doing that, but I guess that's the best way of doing this. You just use 10 cos 60. Alright, so that's that for that. So I'm going to share this video with you, so you can just go there and watch it. Alright, thank you.